students. This is my 7th video lectures on optics, ray optics. We are discussing dispersion by a prism. So this is incident white light or polychromatic light, and then it splits up into its component color. So this phenomena of splitting of white light or polychromatic light into its component color is called dispersion, and the component color obtained on the screen is called a spectrum. Now why this splitting? To explain, we have this Cauchy's dispersion relation, which states that the refractive index denoted by either mu or n varies with this relation, where a, b are the constants for the prism. Now according to this, as the wavelength is more, refractive index is less. So in the visible spectrum we have 7 colors: violet, indigo, blue, green, yellow, orange, red. So the wavelength of the violet is minimum and the wavelength of the red color is maximum. So according to this relation, refractive index for the same material, violet color is maximum and red color is minimum. Now for a thin prism, this is the relation for deviation, a n minus 1, where n is the refractive index. So accordingly, for different color we have these 7 different relations for visible spectrum, and clearly for the violet color deviation is maximum and for the red color deviation is minimum. So this is the cause of splitting. Why white light or polychromatic light splits up into its component color. Okay. Now there are two important physical quantity for this dispersion, which I will give it in your team photograph. That is, one is angular dispersion, which is given by delta V minus delta R. Another one is dispersive power, that is angular dispersion by the deviation of the mean color. Mean color is yellow. Now scattering of light. Scattering of light, when light falls on tiny particles like the molecules or the dust particle present in atmosphere, its direction changes. This is called scattering of light. Now there is a selective scattering called Rayleigh scattering. According to this, if A is the size of the scatterer and lambda is the wavelength of light, and if A is very much less than wavelength or comparable to wavelength, then the intensity of scattered light according to Rayleigh scattering is inversely proportional to the fourth power of wavelength. So this can be utilized to explain this phenomenon. First one is bluish color of the sky. We know that violet, indigo, blue, this end is having minimum wavelength. So its Rayleigh scattering is maximum. Therefore, when the sunlight falls on the atmosphere, then it spreads, these colors spreads all over the sky. Therefore, the bluish color of the sky. Second is reddish color of the sun at the time of sunrise and sunset. At the time of sunrise and sunset, the sun rays has to travel a large thickness of the atmosphere, so therefore Rayleigh scattering occurs, and the color which is having the maximum wavelength will scatter least, that is red color. So red color which is scattered least can be seen from a long distance. That's why at the time of sunrise or sunset, reddish color of the sun is seen. Third is why red color is selected for danger or SOS, save ourselves signal. This is because of the same reason. Red color is having maximum wavelength, so it is having minimum scattering, Rayleigh scattering, so it can be seen from a long distance. Thank you.